Okay, so the last two main concepts for the inheritance chapter that you need to know. First one's inheritance, second one's polymorphism, and third and fourth are abstract classes, and then interfaces. Um, Usually there's an interface written question on the AP test, and they're really easy to write out if you understand the concept of interfaces. And you might have some questions on abstract classes and interfaces and multiple choice questions. But so an abstract class, I always use it's an abstract idea, okay, like a shape, okay. Shape isn't anything real, but um, a shape could be circle or a square or I don't know, hexagon or whatever. All right. So let's see here. Abstract class is a superclass. It represents an abstract concept and therefore should not be instantiated. That means you can't create an object from it, all right? That's like a key idea, okay? You cannot instantiate or create an object from the abstract class, all right? So if I have shape, I can't say shape, my shape equals new shape. That creates errors, okay? Now, let's see here. An abstract class may contain abstract methods. Doesn't have to, okay? We're going to talk about what abstract methods are. An abstract method, but if your class has an abstract method, then the class is abstract, okay? So if there's abstract methods in it, it has to be abstract, all right? An abstract class. So an abstract method has no implementation code, meaning it's just the header. You don't put any information in it, okay? Subclasses whose superclass have abstract methods must implement these abstract methods. So if I have a square that extends shape, and shape is abstract, okay, I have to implement the abstract methods in shape. Okay, we'll see that in a minute. So notice below that perimeter and area are abstract methods of shape and have no body code in their methods, but are implemented in circle and square. Okay, so to make a class abstract, you just say public abstract class and then shape. Notice here's my abstract methods, area and perimeter, right? In semi-perimeter, you just take the perimeter and divide it by 2. That is implementation code. This is not abstract. There's no implementation code in here. That's abstract, okay? So we could say a circle extends shape. Now the reason you might want to do this, okay? Perimeter and area, they're calculated different in circle than they are in, I don't know, what's the next one, square? So in circle, perimeter, we do it as 2 times math.pi times my radius. And area is math.pi times my radius times my radius. In square, perimeter is 4 times my side, and in area is my side times my side. Okay? So we implement perimeter and area in here, okay? Now, polymorphism would still occur if you had an array of shapes, and in that array of shapes, you have a circle and square. Okay. At runtime, the dynamic binding, remember overriding and stuff. You go, oh, use this perimeter for circle and this area for circle. All that stuff still occurs. All right. So let's look at this. We got an abstract class solid, and here we've got volume that's abstract, okay? And we got a sphere that extends solid. So again, solid is abstract. The superclass solid is abstract. Let's see here. Volume is implemented down here where it's just the header up here. No problem. We got a rectangular prism that extends solid. So we do the volume in here as well. Okay. Let's see here. So number one, a program that tests these classes has the following declarations and assignments. Solid. Oh, that can't work. Just telling you right off the bat, that can't work because we can't create. Solid is an abstract class. We can't create an instance of it. That looks good, and that looks fine. What's it asking? How many of the above lines of code are incorrect? Yeah, that line's gonna hose you. The only incorrect line is that you can't create an instance of an abstract class. Abstract classes references can, however, refer to objects of create. Okay, whatever. Which is false. If a program has several objects declared, if it has several objects declared as type solid, the decision about which volume method to call will be resolved. That's true. Okay, I already talked about that. Okay, that's your polymorphism. Still, it works. B, if the solid class were modified to provide a default implementation for the volume, so that means there's code going in volume, it would no longer need to be. That's true. Okay, so if you have implementation code, then it's no longer abstract. Okay. See, if the sphere and rectangular prism classes fail to provide implementation for the volume method, they would need to be declared. Okay, so yeah, if you don't do that, you would also have to declare these as abstract. That's true. D, the fact that there is no reasonable default implementation for the volume method in solid class suggests that it should be. Yep, and it is. And then I guess the answer right here is E, but let's read it. Since solid is abstract and its subclasses are non-abstract, polymorphism, it does apply. So that was false. 3, here's a program that prints the volume of a solid main. So we want to print S gets passed in here from main. Print volume sol. Okay, how is sol is a solid, and it's a sphere, rectangle, solid. These are fine. So we're saying a solid could be a sphere or a rectangle based on the coin flip. All that looks fine to me. Which is a true statement about this program. It will output the volume of the sphere or box as intended. Yep, that works. That wouldn't be true because it is a sphere or a rectangle. Alright, yeah, that question's kind of, it works fine. You guys can read through that. Alright, interfaces. Interfaces are very similar to abstract classes. A few differences. So when you think of when you think of an abstract class, you think of like an abstract idea. Okay. When you think of interfaces, think of using it where you have methods that are alike and could be implemented. Let's see here. An interface is a collection of related methods whose headers are provided but without implementation. So there's no implementation. They're automatically public and abstract. So yeah, all methods are both public and abstract. You don't need to type that in here. It's just, it already knows because they're in an interface, they're abstract, and they're public. Whereas abstract methods don't necessarily have to be public. or abstract. Okay, we saw that up here. Where's okay, get name. That's not abstract right there, and it's in an abstract class. So that's a difference right there that you have to memorize. Interfaces are public and abstract methods. Interfaces are implemented using implement. So if you have a bird, you can implement flying object. So you could show it how to fly, or you can test to see whether it is flying or not. This declaration means that two of the methods in the bird class must fly and is flying. Note that any subclass of bird will automatically implement the interface flying object, since fly and is flying will be inherited by the subclass. A class that extends a superclass can also directly implement an interface. Okay, so if you have mosquito, you can extend insect, and then you can implement the flying object. Okay. Extends clause, it comes before the implements clause. So you call extends, you extend the class, and then you implement your interface. A class can have just one superclass, but it can implement as many. Okay, so you can only extend one superclass. Okay, but you can implement as many interfaces as you want. Okay. So which of the following about interfaces? An interface contains only public abstract. Yep, talked about that. That's true. Let's see here. 2, if a class implements an interface and then fails to implement any methods in that interface, then the class must be declared abstract. That has to be true. You have to implement the methods, and if you don't, they must be abstract. Okay. And 3, while a class may implement just one interface, no, we just talked about it. It can implement as many interfaces as you want. It can only extend one class. Okay, so that kind of had it backwards. So your answer is B. So here's some interface versus abstract classes. Use an abstract class for an object that is application specific but incomplete without its subclasses. Again, I just think of like an abstract idea of something, so that shape idea is fine. And then interfaces, you would use an interface that would have like methods in it. Okay. Consider using an interface when its methods are suitable for your program, but could be equally applicable in a variety of programs. An interface cannot provide implementations for any of its methods. Whereas abstract class, I pointed that out earlier. So interfaces, no implementations. Abstract classes can have implementations, but then those methods are not abstract methods. An interface cannot contain instance variables, whereas an abstract class can. An interface and an abstract class can both declare constants. And then what's this last one? It is not possible to create an instance of an interface object. It is not possible to create an instance. Oh yeah, you can't create instances of them. I already talked about that too. You cannot say, create objects of them. Alright, so I'm going to make a bunch of examples, programs for these, so look out for those, okay?